Alrighty, so right now we're just supplying 12 volts to the circuit from our benchtop power supply, and I have my signal generator currently set to sine wave AC 1.5 kilohertz at about 0.5 volts peak to peak. That is being fed into the reluctor input terminals here for our LM1815. Now, a variable reluctor signal is basically AC whose frequency varies by the number of pulses that are coming past it, and its amplitude also varies significantly with speed, and the LM1815 compensates for that and basically turns that signal into a 5 volts square wave. So the first signal we're going to have a look at is what we're actually feeding into our LM1815. So let's have a quick look. So there we are. It's a nice sine wave at about 1.52 kilohertz. Actually, it's currently at 2.8 volts peak to peak and 1.08 volts RMS. So we can't really use that signal directly into a microprocessor. Now, you probably could, but in the automotive environment, that signal is going to be very noisy, particularly with our AC inverter system. So this is what we're feeding in, and obviously if I vary the frequency, you know, that's going to vary there like so. Now, next signal we're going to see is the output from the LM1815, which is I think on this pin here. Yeah, there we go. So the frequency is the exact same as what we were feeding in, but in this case you will see that we've got a very nice and well defined square wave. Now, the duty cycle of the square wave can be set by some of these resistor capacitor combos, and indeed if we vary the frequency of the sine wave we're feeding in, we vary the frequency that's coming out of the LM1815, and varying amplitude. Basically I've cranked that up to 20 volts peak to peak now, and back down has got pretty much no effect on our signal here. So this nice square wave signal then gets fed into our Arduino Nano, which is just an ATmega 328, and it has a fairly simple job of just reading that frequency, doing some very simple division maths on that to get it to a 2 pulse per revolution signal to feed that to the car's modules. Now that's for a typical V8 it's basically two power strokes per revolution. That's where that signal comes from. So we feed our output signal, which would be just a 5 volt square wave, into a little NPN transistor with a pull up to 12 volts, because again the modules are expecting a 12 volt peak square wave, and that comes out on this wire here. If I can connect to this, albeit with some difficulty, there we are. On our scope now, if I reduce my, we'll see now that we have a much lower frequency, This has been divided down, and we've got a 12.8 volts peak square wave. And if I vary my frequency now, so we can see that that varies as a proportion to the sine wave. So this is kind of the theory, folks. It seems to be working on the bench in a nice clean, with nice clean waveforms and so forth. But let's go chuck it in the Panzer and see if it'll behave in that case. Stay with us. Alrighty folks, so here we have our little circuit just very quickly set up in the car for a test. I've just got 12 volts and ground here, just being supplied by jump leads, just little clip leads just on here. The center wire is my output to the original TD signal from the car, and my input here is on this block, which is my variable reluctor sensor from the original RPM sensor, which is mounted on the gearbox bell housing. So just for the purposes of this test, I'm just going to connect up 12 volts just with these little clip leads here, and then we'll go inside and start the motor up, and with a bit of luck have ourselves an RPM signal. Okay folks, so we're inside the car now, just having a look at the instrument cluster. So I'm going to go ahead and turn the key to the on position. So as you'll see over here, we have warning lights for ABS, parking brake, brake, hydraulic assist failure, and check control. So I'm going to turn the key to start, and hopefully if you keep an eye on the tacho, it should come to life. And it does, it just lifts a little bit. You can see immediately check control and brake pressure lights have gone out. Parking brake is just a normal parking brake. Warning, if I let the parking brake off, that goes out. ABS is a genuine failure. I need to track that down, but anyway, keep an eye on the tach, and I'll just blip the throttle. So as you can see, with our little LM1815 and Arduino Nano circuit, we're now feeding a perfectly legitimate TD or RPM signal into all of the computers in the car that require it. So that's really cool, actually. So yeah, okay guys, so that's kind of it. It's a pretty big step, and it means that I don't have to mess about with trying to get a tachometer signal from the controller. So as always, thanks a lot for watching, and thanks for subscribing and for supporting me, and we'll be back soon.